So Jay is going to be our presenter today. This is actually the first of a three-part series that Jay started delivering at PNEC back in 2017. So this first presentation today is from data transfer to data assurance. Trusted data is the key for good decisions, was presented at the PNEC 2017 conference, and I don't think at the time we intended this to be a three-part series, but as it's evolved, that's what's happened. So we will be broadcasting parts 2 and 3 in June and August, respectively. So watch for notifications of those webinars when they are scheduled. So with that, we have, you should see if you move your cursor down to the bottom of your screen, you should see a button for Q&A. That is enabled, so as you think of questions throughout the presentation, feel free to type your question in the Q&A, and we will have time at the end for any questions you may have, or comments for that matter. We right now have everyone muted. I think I can unmute everyone at some point, but at least I think I can do that if we wanted to open it up, but typically for a webinar we don't do that. It's a little chaotic, and often people don't want to speak up on the webinars anyways, but we certainly can do a Q&A, and if needed we can unmute people if you would like. So with that, Jay, are you ready to go?
Sure, I was waiting to see if Phil was going to make the formal introduction, but I guess he's having trouble connecting. So
no, I think I made a formal enough introduction. So we can get going.
Can you see my slides?
Yes, we can.
All right, well, I guess I'll get started then. Good morning, everybody. And making sure that everything's working. So as Janice said, this is a repeat of a presentation. We've improved it a little bit over the last couple of years, but it's about this topic around trusted data. So we'll have a brief couple of words about Energistics for people who may have joined the webinar who are less familiar with Energistics and what we do. We won't dwell on that too long, and then we're going to talk about searching for trusted data and aspects about trust and trustworthiness scoring. So this will be a little different than, and at the end we'll talk about how standards are able to move scoring about trustworthiness. So a little bit about Energistics. I hope you're familiar with us, but we don't have anything really to sell. We're a nonprofit industry organization, and our role is to help companies manage and share data efficiently through vendor-neutral data exchange standards. We've been around for a long time. We're a successor to the organization formerly known as POSC, and we have around 110 members or so. You know, small software companies are constantly joining and leaving, so it fluctuates, but it's around 110 members. But we have representation from the large E&P companies, Shell, Chevron, ExxonMobil, Eni, and then we have many smaller operators as well, Pioneer, Lundin, Devon, companies in that tier. We have all the major oilfield service companies, Schlumberger, Halliburton, Baker, many other oilfield service companies, lots of software vendors, systems integrators like Accenture, a lot of government agencies, especially regulators or people that run national data repositories in countries. And it's in the interest of all of these people to have open data exchange where you're not locked into a specific vendor. And the standards that we create are in fact the collaboration among the members. So the members are the ones who decide what the data format should look like, and we simply facilitate that conversation. And as we like to say, the standards are created by the industry and for the industry. And Energistics simply makes them freely available via our website and lots of other mechanisms for distributing things. So that's kind of what Energistics is and does. You can look on the slide here and see who a list of some of our members. It's hard to cram 110 onto a slide, so there may be some entities missing from this, but we hope we see your logo on here, and if not, you're welcome to join our community and help promote and develop open data transfer concepts in our industry. So in general, what Energistics supports is our 3 groups of standards whose objective is really universal interoperability of everyone moving technical data in the upstream oil and gas industry. And as we said before, or I said before, they're defined by collaboration between the subject matter experts among our members. And the objective really is to eliminate what one thinks of as data friction. You can think of there's friction of moving data between 2 geoscience applications because you have to write out 6 ASCII files and make data imports and so forth. And we think of that as a kind of friction. It doesn't really add any value to anyone. And if there were simply a vendor neutral way to move that data, whether it's a actively drilling oil well or it's a well header between some technical computing applications, maybe some production volumes between an operator and a regulator, or a measurement company doing a compositional analysis of gas to the operator that's paying for it, or if it's moving data among geoscience applications, none of that friction gets any value for anyone. So defining those data transfers in a vendor neutral way is a really valuable thing to the industry. And on top of that, there's a lot of technology for use in moving data, streaming data in real time. There's a lot of talk about the industrial Internet of Things, and those protocols are all kind of nice, but they're not, in certain ways, they're not really well suited for the kind of data that we move in oil and gas. Some of those protocols are really quite complicated, and they don't carry some of the information that we would like to be able to move. They're not focused on coordinate reference systems and units of measure and those kinds of things. And so our community came up with a simpler protocol called the Energistics Transfer Protocol, and that's gives us what we think of as a Netflix-like capability for streaming data. And when we say Netflix-like, the sort of thing we're thinking about is if I'm going to connect, let's say, to a drilling rig, I don't want the drilling rig to suddenly begin streaming to me every piece of data that's available on the drilling rig, because I may be doing a geosteering application and I really only care about a small part of that. So I want to be able to describe at the time I make that connection, which of the data I would like for the rig to begin streaming to me. And surprisingly, that's difficult in many of the Internet of Things protocols you might have heard of. So our community developed something which works a little bit simpler. It piggybacks on internet protocols, and that's called the Energistics Transfer Protocol. So this, in general, are the 4 things that our communities are focused on now. WITSML for anything to do with the well, but especially the drilling of the well. ProdML for production data. RescueML for moving earth modeling information, especially between different applications that your geoscientists might be using inside your company. And then the Energistics Transfer Protocol for doing anything that involves sort of real-time streaming. So that's a quick overview of the sorts of things Energistics does. And at the end, if you have any questions about that, be sure and put one in the little chat, or if Janet decides to open up the microphone, you'll be able to ask it yourself. But I want to focus on really the topic of today, which is the search for trusted data. So we want to start with the famous magazine article that no one has actually read, but everyone talks about. So this is, in fact, from the Houston Public Library, the Oil and Gas Journal from November 4th, 1991, an article by a gentleman called Lee Lawyer, who was Chevron's chief geophysicist at the time. And he made an article about trends in data management, data handling in the oil and gas industry. And he made this statement that it's estimated that geologists and geophysicists spend an average of 60% of their time searching for data, and added that this effort adds little value to their work. So this number has had a long life and spawned a lot of projects as people attempted to reduce this 60% number. The truth is, this was a little bit lighthearted on his part, because as you can see, he also say that geoscientists spend 5% of their time in coffee breaks and 5% of their time in useless meetings and presentations, and only 18% of their time doing useful work, and that they spend 60% of their time looking for data. So as a result of this article, many data management projects were justified in simply saying, well, let's reduce that 60% of their time looking for data to 30% of their time, because we know we'll never put it down to zero. And based on taking that 30% of their time times the salary of a geophysicist times how many geoscientists you have, that's lots of millions of dollars. And so many data management projects were justified based on this number. And the truth is, it was never true. Geoscientists never truly spent 3 days a week of their entire career searching for data. But over the years, since 1991, that 60%, 70%, 75% number is validated repeatedly by all kinds of knowledge workers. So, and I like to use the term knowledge workers because if you refer to geoscientists and engineers or petrotechnical professionals, then you're leaving out lots of other people who work with data, which is financial analysts, planners. There's actually quite a number of people that work with data in an oil company who aren't engineers properly or data scientists. Production accountants end up using that same technical data. So I like the phrase knowledge workers. Lots of them say they spend this time doing something, but they're not truly spending that time searching for data. What they're actually doing is something that we call data wrangling or data munging, or there's some various terms for this, but what they're really doing is doing the work to create a trusted data set. They download some data from someplace and they try to fix it up and they work on it for a while, and then they ask for some different data and they go back and forth with the data team. And basically they will, anyone who works with data will simply spend as much time as they need to get to the point where they can say, now I'm ready to begin doing my work, my useful work as defined on that pie chart. But when they're surveyed, they simply say, oh, they're spending their time looking for data. But that's just what they said. They aren't really searching in Google or rummaging around in desk drawers or going into musty basements looking for tapes. They're really spending quite a lot of time, but what they're doing is building up a set of what they feel is trusted data. So I want to talk a little bit about trust and what that would actually mean to have trust in either a source of data or in a piece of data itself. So let's have a couple of definitions of trust. The Oxford English Dictionary says it's a firm belief in the reliability, truth, or ability of someone or something. So in fact, if you're a data manager, the fact that you manage a group of sources of data which contain data, the trustworthiness or lack of trust that users have can refer to all three of those things. And it can personally begin to refer to the trustworthiness of the people involved in the data management staff in addition to the sources of data and the pieces of data. So that's why that someone or something is interesting. And then there are some other, there's lots and lots of amusing memes from the internet, if you like, little phrases that people will have heard. You know, once trust is like paper, once it's crumpled, you can never make it perfect again. It's like an eraser. Trust gets smaller and smaller after every mistake. Even Albert Einstein said, whoever is careless with the truth cannot be trusted with important things, in small matters. And then, of course, if vodka tells you that you can dance, are you really going to trust vodka's word for that? Probably not. So trust is a thing that people concern themselves with. There's a lot of psychological research on trust. And as Janice said, this talk has evolved into a series of 3 talks. And in the second and third talk, but especially the third talk, the psychological aspects of trust and betrayal of trust. I go into much more detail about those. And you might like to listen in on those webinars if you're interested in learning more about how trust is gained and how you as a data manager handle a situation when trust is lost in your data store. How do you get that trust back? But it is kind of a psychological emotion. And here's the kind of thing that causes users to lose trust. So this happens to be a satellite image that the Satellite Imaging Corporation lets me use. This shows some Libyan data, and you can see the red dots are places that the database says there's a well, and then in fact there's little square brackets that the satellite has identified where a well is. And you can see some of the well spots are as much as 1 kilometer wrong from where the actual well is. And there are some red spots that don't seem to be related to wells at all. And then there are other wells where the little brackets are drawn that there is no location for in the database. So maybe one of these red spots, in fact, is related to one of those wells on the ground, but it's so far away that you can't tell what it's related to. So if a user downloads your well locations from this source of data and then simply puts it on the satellite map, and there's this much error, the users will then immediately realize that I can't trust this source of data for well locations. If it's my only source of data for well location, then I'm going to spend the next couple of weeks getting original data, emailing the national oil company or a service company, and because I can't do my work unless I accurately know where the wells are located. So I'm now stuck trying to get data that I can trust. And that's the sort of thing that we're talking about. They very easily found the data from their company's official data source, but then when they found that they couldn't trust that source of data, then they have to go and try to find alternate sources or investigate systematic errors that could be present in the company's trusted source of data or official source of data. And that's the real struggle that people have. Or you lose trust when you see data like this. So many companies will have technicians that will put workstation-ready data into a geoscience application. So this is an example of data where all the reference elevations were lost, all the directional surveys were lost, so the wells all look like straight holes. Some geoscience application thinks depths are negative numbers, and most of them think depths are positive numbers. So one of the surfaces is flipped upside down. As a geoscientist, if you get this put into your favorite geoscience application, you're going to shake your head and have to go back to the official source of data, pull that flipped upside down surface out into some kind of file, multiply everything by -1, fix the data yourself. You're not really looking for data. You've found the data, but you have to fix it. You know, the problem with the elevation references happened to be that it was called Kelly bushing in the official source of data, but it's called KB in the geoscience application. So you have the data, they just didn't make a proper mapping from the official source to your particular geoscience application. So again, you're not looking for data, you're fixing the data as it came from that official source. So basically, knowledge workers of all kinds, geoscientists, engineers, financial planners, whoever they are, production accountants, they will fix their data because they don't want to do a bad job. They will do whatever they have to do and take as long as they like in order to actually accomplish the work that they've been tasked with. It's a really common story in the data management world that what will happen is one of these people will simply fetch all of the data out of the official source of data, and they will put it into Excel or whatever technology they are comfortable with. They'll make all of these fixes like we described. They'll flip that surface upside down, they'll spell KB correctly, and then they will move on ahead with their work, but they'll tell their coworkers that, oh, I fixed up all that data from the official source. So pretty soon, everybody on the floor will stop using the official source of data and will start using the source of data from that knowledge worker that made those fixes. In the official world of data warehousing, the data warehouse guys call these rogue data marts. And that seems like maybe a good thing for a while, but there ends up being two huge disadvantages to that. One, obviously, as changes are made in the official source of data, improvements or additional information, that copy that was made 6 months ago doesn't reflect those changes. The other thing is the user who made those changes, let's say the changes they made were they updated the Kelly bushing to KB and they flipped that surface by multiplying it by -1, but they only made the changes they needed for their use. So their improvements for a particular work purpose that user had, that may not be the same purpose that you're going to put that data to, and in fact, it could be worse. They could have done something which is worse than the official data for your particular purpose. So at the end of the day, the time that people have spent in using that bad data, bad decisions could have been based from it. Whatever decisions get made, there ends up being time fixing those decisions and having to repeat fixes from the official data source. So the bottom line is that once users lose this trust in the official sources of data that a company has defined, then as these rogue data marts begin to spring up, there's a great deal of wasted money and wasted effort. The time obviously would have been better spent in having a nimble process that allows people to point out these flaws in the official data sources and fixing those official data sources to begin with. But if those fixes are made or not made, how are users ever supposed to know about this stuff? So that's what we're going to talk about. So let's talk a little bit about trust, and specifically about trusted data. And as I started investigating to see if there was anything in the literature from other domains, medical, aerospace, of a source of information that actually defines trustworthiness or trust. And I differentiate between those two words a little bit. Trust is a feeling that you have in a person or a thing, like a source of data, but trustworthiness is actually something, it turns out, that can be scored numerically. I can look at a piece of data and there are ways that I can describe the trustworthiness of that data for a particular use. And I found some interesting research done by IBM. There's a slide at the end of the slide deck that gives the citation for one of those papers, and from the references in that paper, there are other locations of additional research that you can access if you really want to go and research this more deeply. But the really interesting thing about this work was that it defined a specific list of things that you can use to create actual numerical scores of trustworthiness. And we're going to go through that, and that's the what a large part of the presentation is going to be about. And so I've added into this research a couple of things that are specific to the oil and gas industry. So my list is a little bit different than the list that you'll find in that underlying research, which was more generally about trustworthiness of data. So in general, these characteristics fall into 3 dimensions. One relates to, do you trust the source of the data, and your level of trust becomes a score of trustworthiness of the data that comes from it. The second, do you trust the way the data has been handled since it was measured or originally created? And thirdly, do you trust that the data hasn't been tampered with in a hacker sense since it left its source? And we're going to go in a little bit of detail through all 3 of these things. The first of the dimensions is whether I trust the source of the data. And this dimension covers several different facets, and we're going to use this word facets to describe the sub things within one of those dimensions. The first of them is believability. So when you get a piece of data from a source of data, is it believable? Is it sensible? So a good example of this would be, is it complete? So if I get a latitude, is there a matching longitude? Do I know for that latitude and longitude whether it's in WGS 84 or NAD 83, what the coordinate system is for that? So is it complete? Is it within a reasonable range? So if I get a latitude and longitude and it's one of those numbers is 500, then it's not within a reasonable range. Is it the right data type? So is it a floating point number? That kind of thing. So there are some sensible rules that you can easily apply to data, and those sort of things can develop a score for the believability facet that you get from a source of data. And parenthetically, data quality engagements that companies commonly go through, that's the facet that they're able to measure easily by inspecting the data in a database. The second facet within this source dimension is the reputation of the database. So the reputation contains a couple of interesting things. One is many companies, if not most companies, will declare a source of data to be the official one that you're supposed to use. So that should improve the reputation of the data source, because some group of knowledgeable people have said this is the official source of truth that our company is supposed to use. And while that may be true, there's an additional aspect of reputation, which is, what do your coworkers think about it? So a community may develop that thinks that this is a bad source of data, or it may be that people up and down the hall will say, no, the data is really good from this source. So that's a little bit different from it being declared the official one by the company. And then, of course, any individual knowledge worker may have had a previous bad experience with that source of data. So again, those are the sorts of things that it's possible to score, but you can't just troll through the database and develop that score using some automated tool. A third source, a third facet within this source of data trust aspect is there a potential for there to be a bias? Now, that isn't normally a problem for the kind of measurements that we use in upstream oil and gas, but you could imagine that if we're talking about data in a public survey or some kind of a poll, then you could question whether there's a bias associated with that source. The place where we see this the most often, I think, in upstream oil and gas is about perspective. There are lots of different perspectives. You may have a GIS perspective on a data source versus a petroleum engineering perspective versus an academic researcher's perspective. And so there may be perspectives that are reflected in the source of data that may cause you to think that, well, I might want to use that source of data, but that's done by the production accountants. And, I'm not sure if I really want to use the volumes that the production accountants have done with their allocation methods in my reservoir simulator, for example. So it doesn't mean the data is wrong. It just means it was developed with a particular perspective, and that could bias somehow the numbers in a way that you would choose to not use or to trust a little bit less and associate a higher level of uncertainty with. And the fourth facet is about reliability. And in this sense, is this particular source of data in general known to give good information? So if I have a hook load sensor on a drilling rig, it may be known to be typically not the best kind of sensor because it's a load cell on the anchor leg of the anchor of the drawworks, or it may be a quartz load cell up on the traveling block, and that's normally a sensor that gives good information. But maybe it only gives good information if the temperature outside is less than 100 degrees Fahrenheit and the actual temperature outside is 120 degrees Fahrenheit. So maybe it's not so reliable under those circumstances. So those are the sorts of things that you'd want to know about in order to give a trustworthiness score to a piece of data. So these are the facets within this source trustworthiness dimension. The second dimension was trust in the handling of the data. So the handling of data, the first one is origination. Do I actually know what the source of data actually is? We may get lots of data and somebody may say, I don't know where this data came from, but this is the data that we have. So are you going to consider that data to be very trustworthy? Probably not. The second facet within this handling dimension is traceability. So assuming that the source of the data can be identified, then can I actually see what has happened to the data since it was measured? So is that lineage available for me to look at? I might not choose to look at that lineage, but I will trust a piece of data more if I know that I could look at that lineage if I needed to or wanted to. So that's why this is phrased in this way. Is the lineage of the data available for inspection? Simply having it available improves its trustworthiness. And then, of course, has the data been processed? In fact, a lot of data is calculated data. A flow meter is always a calculation because I can't directly measure the flow of anything. I can measure pressure upstream and downstream of an obstruction like an orifice plate or a venturi, or I can listen to the sound of the fluid rushing by and correlate that with flow rate, or there's lots of different ways to try to calculate flow rate, but it's always a calculation. So if it's been processed, I want to know what algorithms and parameters were used. And again, I might not inspect that data, but the fact that I know that I have that data information available to me will improve my trust in the data. And in fact, if there's a question, that's the sort of thing I'll go into and see, oh, well, they used the wrong correlation when they calculated the pressure drop across this orifice plate. So let me go back to the original data, the pressure upstream and the pressure downstream, and I'll put the right algorithm in there. So instead of using the official calculated data, I'll go back a step and I'll repeat the calculation of the flow rate based on the pressure data. So my analysis will simply have an extra step in it. So that's the sort of thing that knowledge workers need to be able to use, have access to in order to have trust in that data source. The stewardship status of data is an important facet. So I really want to know, was the piece of data measured or came from a computer, or was it manually typed in by somebody? So in fact, the Kelly bushing example I was talking about before is simply a matter that somebody typed in the word Kelly bushing as opposed to just typing in KB. So that's not something that's automatically captured. That's something that's manually entered. So you have obviously less trust in data that's manually entered than you do that was captured automatically somehow. And finally, for data that's calculated or which has been processed somehow, it's often important to know what software did they use, what version of the software, which of the algorithms is in the software, what were the settings, and more important, what user was involved in creating it. Because if it was a summer intern who calculated a bunch of data, you'll have less trust in that than you would in a senior geoscientist who may calculate the same information. And the final aspect is about security. This is not often a problem in oil and gas, but it can be a problem, and the access of a knowledge worker to this kind of information improves their trust in the source of data and in the data which comes from it. So I have a few things listed here. Specifically, has the data been secured since it was measured? What has it been in an environment that the general public has access to? Could students have gotten in there and changed it accidentally, or maybe some inexperienced technicians? Is there indeed a process for users to identify themselves at all, or could anybody register themselves in the system, which means that some bad actor could have registered themselves under a fake name and done something bad to the data? Is the data source itself, does it use roles? Meaning, does anybody who self-registers in a system, can they delete data and write data, or can they only read data? Does the system keep track of who made changes to data? So if you look at a piece of data and you find that it used to be correct and it now no longer seems to be correct, can you actually see who made that change and go back? Another question that many knowledge workers concern themselves with is about licensing. I find some data in my company and I want to use it in my analysis, but am I legally allowed to do so? Maybe there's some really good data that I know exists in another country, but it turns out that that other country doesn't allow that data to leave that country, so I can't legally use it, and I'll cause a problem for somebody that if I somehow can access that data, I may illegally bring it across an international boundary. And then finally, a disclosure policy. So if the objective of my work is to write a paper that I'm gonna present at a conference, I need to make sure that the data that I'm using inside my own company is going to be a set of data that I will be allowed to disclose the results of to the public. Otherwise, I may choose to not use a proprietary source of data inside my company and find something from the outside world or something that my company is comfortable that I'm going to disclose those results to the outside. People often don't think about this when they're doing academic work in oil companies. So that's the facets of trust. So given all this, it's really clear that the users are indeed, knowledge workers of all kinds, are indeed spending a great deal of their time doing something with their data. They're not really looking for it because they found it. But once they brought it into their application, they discovered it wasn't adequate for the purpose that they want to use it for. So then they're doing whatever changes are necessary to that. So that's really kind of clear. And as we said in the previous discussion, even for a trustworthy source of data, users may not ascribe trustworthiness to that source because they don't have access to know, was this typed in or calculated? If it was calculated, what was the source, the original source of that calculation, and what settings were used and what software were used? Who's worked on it? You know, if I know that I have access to all of that information, then I'm going to trust that source of data, whether it's the official one or not. I'm going to trust it much more. So, given that that's true, what the industry really needs is some way to actually convey information about those aspects of trustworthiness. And people will commonly think about this as data quality. So our communities, you know, especially the WITSML drilling data community, but with participation from all of our communities, a group of people came together to think about data quality in the context of transferring data from one place to another. Because often a source system like a geoscience interpretation package or an electronic data recorder box on a drilling rig, there's information that software knows about that relates to these questions of trustworthiness, but normally that data isn't moved, that trustworthiness data isn't moved alongside the data itself. So in the group which began to think about data quality realized that data quality wasn't the appropriate concept to be talking about, and so they actually switched themselves to thinking about something that we call data assurance. And data assurance as a concept is a little bit different from data quality. In the world of data assurance, one basically establishes, an operator typically establishes a policy. And let's say I have a well-logged data quality policy or a well location quality policy. And a policy is a set of rules that you expect data to conform to. So the data assurance group worked to make certain that the Energistics data transfer standards have a way to describe those policies and rules, and then to move a description about those policies and rules along with the data itself as it moves from one system to another. So that requires us to, in addition to moving those data assurance policies, to have traceability of the data so that you can see what the sources and calculation techniques, as I described before, which software versions were used, when things were calibrated, how they were calibrated, all of that kind of information that would help give users trust in data by having those dimensions of trustworthiness be quantified. We want to make sure that our data transfer standards are capable of handling that. So the truth is, we have done that. And we do that through two mechanisms: the use of an object which is simply called data assurance. And the other way that we go about doing this is we have an explicit activity model that allows you to describe any kind of activity. That might be a calibration activity, that might be a water saturation calculation activity. It might be any number of activities, a real activity done in the field, or a computing activity done automatically, or an explicit interpretation activity done by a human. But any kind of activity can be described along with the data that was used as input to it and a knowledge of the data that was produced by that activity. So all of this kind of stuff falls under the rubric of metadata, which I won't go into a great deal of detail here. But if you tune into the third talk in this series, there's a lot. We go into a great deal of detail about metadata, but in general, everything in the Energistics MLs have a certain amount of information, like you'd think. You know, you can see when something was created, when it was updated, what software created it. Does it have an alternate name? So I may call a well the Daisy Smith number 3, and Shell thinks it's called the Daisy Smith space NO period 3. You're allowed in the Energistics MLs to put any sort of additional metadata that you may find appropriate as extensions to the data model in a case where you find something that's missing from the official data schemas of the Energistics transfer standards. So we have several ways to do that. And then I talked, of course, about the use of this little activity model. So I really don't expect everyone on the call, to be an expert at looking at UML diagrams. But basically, the data assurance object is a simple little thing that attaches to, if you're looking at the UML, it's the blue thing, but it attaches to any of our objects. So whether that's a well object or a wellbore object or a grid from RescueML or a well test from ProdML, it doesn't matter. You can describe the policy, the data policy for that, and any rules associated with that. Now, typically, if a piece of data passes the policy, we don't bother to put that on the wire, because we expect that measurement companies, they're contractually obligated to conform to these policies, and so we expect the data to conform to those policies. So we typically only move information about policies that would be failed, but the key thing is the data still moves along. So for example, if I had a policy with a rule that says the sensor needs to be calibrated every 30 days, and it's been 6 months since the sensor was calibrated, I still need to send you that data because that's the only data that we have. But I need to let you know that the piece of data I sent you fails a rule within your company's data quality policy, and it fails the rule that says the object must have been calibrated within the last 30 days. So here's a little example, and there's a comment here, you know, that it fails a particular policy, and the policy would have been that the wellbore must be within 10 feet of the planned location, and the wellbore surface location is actually 28 feet, so it's failing that particular policy. So again, a policy is one of these things like this 101 or 102, which consists of individual rules. So another example from log data basically would be, you know, all curves must have a calibration tag. The calibration must still be valid. And then I have quite a few rules that are defined in this little box. And these are more like data rules, where you can actually infer from the data itself that I expect the value of curve X must be above the value of curve Y, but in this case it's not. This particular policy failed because I should have been receiving data every 15 seconds and there was a gap, so there's a policy failure. So there's quite a few rules within this little policy, but many of these could be inferred. But the thing that you can't infer from simply looking at the data is the sensor calibration still valid? I can't see that from inside the data. I have to have that information someplace else. And being able to convey not only that the data failures came on the data that I could see from the data, but also policy failures that could exist that I can't infer from the data. And the data assurance object lets you move all of those. And finally, you know, to close off, we're not going to go into the details of this, but basically, and I have just a scrap of a UML diagram, but we have this activity model As I said before, it can be real oil field activities like doing a calibration in the field, or I'm pulling out of hole, whatever it is. You know, I can have real oil field activities, or they can be activities in the office, either done with a computer or done by a human. And you can describe basically any piece of data, what were all of the pieces of data that fed into it, what software was used to make the calculation, and what were the settings and parameters used within that software. So on that note, I'm going to be finished and open the floor up for some questions.
Okay, thanks, Jay. So as Jay said, the Q&A is officially open. Please, if you have comments or questions, feel free to type them in. Henri Blondel had a comment, really, and if you, I've actually unmuted you,
All right.
Henri, if you want to, at least I'm trying to. You might need to unmute yourself, actually, if you want to expand on your comment.
Do you hear me?
Yes, we do.
Okay. Hello, Jay. Thank you for.
Hey, Henri.
No, I did a comment because that's a point, but you have replied a few slides later to explain the relation between trust and quality, and I agree with your relation. And by experience, I think that what we are frequently missing in the upstream data is all the metadata about the transaction of the information. And we are very good to store plenty of static data, but frequently not enough of transactional data to know the source of the information, or even just the document from where it comes is rarely mentioned. So.
Good. Well, I hope I answered that, at least from our perspective, is that we want our data transfer formats to be able to carry that information.
Yeah.
If the source system has it available, we really need to be able to carry that along with the data, and that's an important aspect of it as well. Having that information moved along with the data is important so that it doesn't somehow get separated and lost.
And maybe another comment, you start your talk saying that 60% of the time of a geoscientist is to check the trust. That is true, but I don't think it can be reduced to zero. I think to make your dataset trustable, you need to spend some time to double check some few things yourself. Or just check that the conveyor has done the job. And as all the information you have mentioned.
So I agree, and in a later, one of the two later talks, I go into some more detail, I suppose, about that. But really, there are people who think this is a waste of time, and I and many other people say it's not a waste of time.
No.
In fact, the knowledge worker, in the process of checking through the data, fixing this little problem and that little problem, they actually make quite a lot of observations while they're doing that before they've officially started doing their interpretation. They're able to make quite a lot of useful observations while they're doing these fix-ups. It's not a total waste of time.
So Jay, on the point about time, Bracken asked if you could comment on the value or time spent describing data assurance objects versus specific data types used in subsurface. So while you answer that, I'm going to mute Henri and unmute Bracken in case he has a follow-up question. So why don't you go ahead and start, and I'll find Bracken.
Yeah, I'm actually not sure. I'm actually not sure what he means. The time spent describing a data assurance object. You know, the hope is in the third of the three talks, we cover this in more detail, but the vision of the industry is that this information, no human would spend any time creating these data assurance objects. The metadata that's described in those objects really many times could be coming from a source computer system itself. So like in a geoscience example, you know, your interpretation application knows what your coordinate reference system is, and if that's the one you should, and it knows who the interpreter is, and it knows what version of the software it was, and it knows what parameters were set, and you know, the hope is that much, if not nearly all of this metadata is contained in a computer already someplace and should be able to be moved automatically in a data assurance object. And my thesis in this and the subsequent talks is that users, I don't think, are really going to spend a lot of time prowling around and looking at those things, although they will do some of that, just a spot check to make sure that the data seems like it's kind of okay. But what gives the user a level of trust isn't so much that they've done all that checking, it's the fact that they know they could. That's what helps people trust a piece of data. I know I have access to this information. I check one or two of them and it seems like it's kind of okay. And I'm confident that if I see a problem someplace, I know I'll be able to go look in those data assurance objects. So that's what gives me that little level of trust. It's a little hard to understand that we don't expect people to inspect everything, but just the fact that it's available gives people confidence.
So Bracken,
Did that make sense
does
to
that
you,
answer your
Bracken?
question?
Yeah, actually, this is Pilar. I'm sitting here with Bracken. Yeah, it does make sense. Are you referring really only when you transfer data from one place to another? One of the things that we find is that a lot of that data that you mentioned that is inherited, like who did it, what was the source, when was last calibrated, kind of gets lost. So people start saying, yeah, I don't trust data unless I know it's from this specific person, or a lot of that. And we're just trying to see if we are going to set up a program or if we are going to be working on it. To be honest, it's like you have to come up with this balance. How much time and how much effort are we going to spend on the data type, saying, okay, we actually did all of these, and this data assurance object describes it, so that our users start trusting the data.
Well, one reaction I would have to that, if you watch the second webinar, sorry to keep talking about these future webinars, but if you're able to attend the second webinar, one of the things that is one of the conclusions from that is that in order to have access to much of this metadata, if you're going to create a data management program in a company, there's other kinds of data that data managers haven't historically managed that you need to think about. For example, if it's useful to your user to know when was a sensor last calibrated, the truth is that's probably in your maintenance management system. So that's going to be in SAP or Maximo or whatever product you use for maintenance management. Well, our data managers typically don't think about data managing that and making that available to users. But the truth is they really need to know when that sensor was last calibrated, for example. Or if you need to know for this particular brand of sensor, after it's calibrated, what percent per week does it drift away from that calibration? That drift value is available in the catalog from the vendor that made that data, and it may be available in your procurement system. A data sheet from that may be available in your procurement system. So that's the place where the user is going to go to look that up. So it was kind of a challenge to the data management community that if you're creating an engagement like that, to think outside the box about sources of data that are definitely available inside an operator that data managers haven't historically thought about. They're typically focused on their OSI soft PI data and you know, the typical geoscience data values that are measured in the field, or my stream of WITSML data coming from a drilling rig. There's all these other sources of data that are key as well, and we'll talk about that quite a bit more in the second webinar.
And on that note, we've reached the end of our time. Sorry to end on a cliffhanger, but join us at the end of June when we will have our second in the series, and it actually escapes me at the moment what we called it, but I believe we've scheduled it for June 27th, and there will be an invitation going out. So we hope to see you and hopefully some others back for part 2. We will be posting the recording of this webinar as well. So if you want to go back and listen, or you have other people in your organizations that you'd like to listen to this in preparation for the next 2 parts, watch for the notification that that video is available. I want to thank everybody for joining us, and we look forward to seeing you in June. Have a great day.
Thanks, everyone.